when we drive a normal driving condition, all this dynamic couldn't be felt so much because of the effect of suspension system. Okay, but we do at high speed driving or reckless driving, then you can basically understand what I was mentioning in the vehicle dynamics here. So as the car is moving fast, okay, and under extreme driving conditions, so sometimes there will be some shifting in the direction or in the distribution of mass. Like I said, the center of gravity has shifted, so the car is basically, we call it yaw, or if you look from the top view, the car is twisting in the right or the left position. Okay. The second type, okay, of vehicle dynamics, which I'm going to talk today, is the longitudinal dynamics. This might normally happen during extreme braking or accelerating. Okay, say for example, you drive at very high speed, and suddenly you saw or you see something is crossing over the road, and you press the brake, okay, emergency brake, then you can feel that the rear part of the car is basically shifted up a bit as compared to the front part. Or for example, you are resting at a traffic light and suddenly you saw something is chasing after you. So you're going to get over or you're going to run away as fast as possible. Then you press a brake, you press, sorry, the pedal all the way down, which means that you accelerate at very high magnitude. So you can see also the effect that the front part of the car is basically lifted up a bit. So the effect can be clearly be seen for heavy vehicles, for example, buses, lorry. For car, it's not much, I can say, based on my own experience, it's not much can be felt, but if you drive a heavy vehicles like trucks, buses or lorry, or even vans, then you can see clearly or you can feel distinguished effect of accelerating and braking at high or at extreme driving condition, which I have mentioned just now. All right. The third type of the vehicle dynamics is the vertical dynamics, okay, which is the motion up and down, the vertical motion. And this one is mostly due to the road irregularities. So there's no such thing as smooth road. All the road has some, well, in engineering, we call it the function that define the road, we call white noise, okay, which is a random uh, function that we define for the road. So these irregularities of the road will be transferred in a form of vibration, okay, and then it will be transmitted to the passenger or the person inside the car. And it gets worse for off-road vehicles. Off-road vehicle, especially for four-wheel drive moving between the mountain trails, okay, in the river like this, okay, on a sandy condition. So the vibration will be transmitted to the wheel, okay, and then further up will be transmitted to the person inside the car and also the driver. So the bad thing is it can cause discomfort, okay. So if we're exposed to this vibration for a short period of time, it's not really that much effect, okay. But the effect will be if you're exposed to a prolonged vibration or prolonged discomfort. For example, based on the research which I have done in the previous university, the acceleration of the vibration as low as 2 meter per second square is very low. Yeah? The magnitude of 2 meter per second square is quite low. But if you're exposed to this for over 8 hours, especially for a long journey, okay, so it can cause damage our body. And sometimes, if even longer, it can cause permanent damage to our body. The first damage will be you can feel the sensation of numbness. And then your vision will get compromised, you get blurry vision, okay? And sometimes it can get fatigueness. So this effect or this hazard will be transferred to our body because of the dynamics of the car. So we have, which I have mentioned just now, we have three categories of dynamics of a car. So what the suspension is for is basically to counter all these dynamics. So the vibrations that goes to our body, the movement of the car back and forth, up and down, left and right, rolling motion. So these can be controlled by means of the suspension system. So if you think that, okay, well, I don't really care about my body, I don't really care about getting fatigue or vision compromise, a blurry vision or numbness on my body, or I don't really care about if my car get rolled over and got accidents happen and everything, then you don't need the suspension system. But if you think, oh, that means, sorry, Dua, the magnitude of the vibration that is being transferred to our body. Okay, so at a rate of 2 meter per second, at a rate of 2 meter per second, so it's quite small. But if you're exposed to that for a very long time, it can cause, well, it can cause basically they call discomfort. But if you exposed to a very long time, then it can cause damage to our body, which I have mentioned just now. So like I mentioned just now, yeah. So if you think that you require the vehicles just to bring you to one point to another, you don't really care about your comfort, you don't really care about the handling, okay? So then you don't have to install the suspension system, so it's not required. But if you think that, okay, my body is, I like my body, I don't want my body to get damaged, I don't want my body to get numbness, or God forbid the permanent damage, tissue damage, or your nerve damage because exposed to a very long or prolonged vibration. And I don't want my body, my vehicle also to get damaged due to the dynamics of the vehicle, which we discussed last time. Then the suspension system is a must to be installed to our vehicles. Okay, again, like I said, I'm talking about the land vehicles, okay, not the air or sea, because the land and sea, they have different types of dynamics, right? So that is basically the justification. Why do we need the suspension system for? Okay, so to control or to counter all the motion, all 6 degrees of freedom of motion of the vehicles, in order to save ourselves, our body, as well for to save our vehicle from getting damaged. Okay, right. So having known that, okay, what is a suspension system? Okay, we know that the suspension system is used to counter all these dynamics of the vehicles. So, and I have mentioned just now, the suspension system, it has two main purpose. One is for handling and one is for comfort. The comfort is the safety, the one that I mentioned due to the vertical vibration that is being transmitted to the body. Okay, the handling, meaning that we want the tire of the vehicle to be remain intact on the road throughout the journey. So we don't want one of the tire to lift off from the road and cause accident or cause the vehicle to roll over. Okay, we don't want. We basically want the level of the vehicle to be remain at the same level throughout any driving condition, whether we hit the speed bump, something on the road. Okay, we hit that particular object on the road, so the level of the vehicle and the wheels or 4 wheels of the vehicle remain intact with the road. Okay, so in general, I'm talking about general first here because, like I mentioned in the previously, that there are 3 different types of suspension. We have passive or conventional suspension, we have semi-active, and we have active suspension system. So in general, okay, for passive suspension system, it has few components. The most important are the spring and also the shock absorber, which you can see behind the wheel. Okay, because like I said, I can say more than 90% of the vehicles now are still using passive. Okay, so you can see the spring and also the shock absorber behind the wheel. And that spring and shock absorber, the spring is used to absorb the energy, and the shock absorber is basically the element to dissipate the energy. Okay, apart from that, we also need linkage, okay, or linkages that connect the suspension to the body of the vehicles. Okay. All right. So this is one of the example of layout of a suspension system which is installed to the vehicle. Okay, and this one's for the car. Yeah, we have generally we have 2 ways of doing it. We have dependent and also independent suspension system. Okay, the one that we have most of the time is mostly independent. Independent means that they are installed to each of the independent wheel and they work independently with respect to the road conditions and also the dynamics of the vehicles. Okay, they don't depend on each other. Okay, some suspension system, some vehicles, which I believe they still be applied for some heavy vehicle, but not car. For all cars, they are all using the independent suspension system. But for trucks, pickup trucks, I've seen with my own eyes, some are still using dependent suspension system. So how do we differentiate between the two? For independent, okay, the effect or the works of the suspension is independent to each other. Okay, for dependent, normally the two wheels, the front wheels here, normally they are connected by an axle, and the suspension system is attached to the axle. Well, I will explain. I think I have a slide for that one. I will show you that. Don't worry. Okay, so the effect of the rear of the front left wheel also can be controlled by the suspension on the left hand side. So this is the dependent one. So most of the car, I can say 100%, I'm not saying it's most, I think 100% of the car is using independent suspension system. Okay. All right, on to the layout of the suspension. Like I mentioned just now, we have independent and also independent suspension. So the suspension, it has few components. Okay, I think let me show you from this figure here. It's easier to see. Okay, this is one of the type of suspension here. This is a double wishbone suspension. You see, this one is the linkage. So in our suspension, this is our spring and absorber. Okay, together here. This is the spring and the shock absorber is inside here. And this is the linkage which connect to the chassis to the bar. In this case, we have two. One is upper and one is lower. And this one is what we call knuckle or the upright, which connect to the wheel. All right. So, like I said, there are three different types of suspension. Okay, we have conventional or the passive suspension system, we have semi-active, and we have active suspension system. Though there are some argument in the form of some researchers say that there's no such thing as semi-active. It's only passive and active. Some researchers says no. We agree that there's clear difference between semi-active and active, but in terms of definition, it's not really that important. But the most important thing is for passive suspension system, how do we define that? Is a suspension which doesn't require any external power. So any suspension, whatever the shapes, it can be in the shape of shock absorber, maybe in the shape of something, but it has the same effect of shock absorber and also the spring, as long as it doesn't require any external power to run the suspension, then we put it under the category of the passive suspension system. Okay, for semi-active, since I say that there are argument going on within the definition of the semi-active and active, so the one that I'm using here is for semi-active, we still keep the conventional suspension system, meaning that the spring and damper is still there, the spring and the shock absorber is still there, but on the top of that, we introduce another actuator, for example, hydraulic, pneumatic, electromechanical, magnetical. It can be any type of actuator combined together with the conventional spring and damper. Okay, and since we require external power to run the actuator, now we call that suspension system as a semi-active suspension system. The last one for active suspension system, okay, the difference is we remove completely, okay, now the conventional spring and damper has been removed completely, okay, and then we replace with a single actuator. It can be in any form, like I said, it can be hydraulic servo mechanism, it can be pneumatic, a combination of hydraulic and pneumatic, it can be in any form. As long as we remove that, then it becomes an active suspension system. If you look at the definition of semi-active and active, it's almost similar. They both require external power. That's why some researchers say, or some people say that they're all the same. So why do we have to split into two? So it's up to you, okay, whether you're going to call them all active or you're going to call them some semi-active, some active. But the common between the two is they both require external power supply. For conventional passive suspension system, we don't require any power supply to run the suspension. Okay, and for active, sometimes they call as well adaptive suspension because the suspension will adapt to the driving condition, road condition, and also the dynamics of the vehicle itself. Okay, so if you have any question, so you can always ask me, can write, or you can write in a chat box here. So I can ask question uh, throughout the presentation. Okay, right. So first, I'm going to discuss about the conventional. This is the earliest suspension system type that we use. Okay, one of the type of the suspension system or the passive suspension system is a double wishbone. Okay, the reason they call it double wishbone is because of this shape here. You see the shape here? The lower arm and the upper arm here is a shape of the wishbone. Some people call it a double E-arm suspension system. Okay, so the arm here is connected by a ball joint here. So since this is a ball joint, so it gives some flexibility in the form of the direction of motion. So one of the advantages of the double wishbone here is has very flexible, so it can cater many degree of freedoms of dynamic, which I have discussed just now. So remember, we have 6 different types of freedoms of the motion of the car. So for double wishbone, it's basically it can cater most of the degree of freedom. So it's one of the good suspension system. Okay, but and also we can control that by means of the we can control the performance by means of the length of the wishbone here, okay, the arm here, and we can also control the performance by means of the angle of the arm here. Okay, so by controlling that, we have a good effect in terms of handling and also the comfort. But we don't really get both at the same time, but at least we have a good performance in the sense of slightly good comfort and slightly good handling, because remember there are two purpose of the suspension system. One is for handling and one is for comfort, and sometimes most of the time, sorry, not sometimes, most of the time, the two objectives, they are contradict to each other, meaning that if you want to have a good comfort, you have to sacrifice the handling. If you want to get a good handling, you have to sacrifice the comfort. I will explain that later once before I move on to the active suspension system, don't worry. So for double wishbone, it can get a good degree of comfort and a good degree of handling at the same time by changing the direction or changing the length and also the angle of our wishbones here. Okay, so this one, in terms of the application, nowadays, not many cars are using it. Okay, the reason is because the design is quite complicated, hence it's a bit expensive. Okay, and if cars are using this, they normally install this for rear suspension. For front, they use different type of suspension because of I think one of the main reasons is because of the price, because of the cost it can incur due to the complexity in the form of the design. The second type of the passive suspension is the McPherson strap. Okay, this is the one that normally used. Most of the car, I can say 90% of the cars are using this. Okay, all brands of car, all models are using this McPherson strap. Yeah, so most of the car they use for both rear and front suspensions. Some of the car, like I mentioned just now, the front part they use McPherson, but the rear part they use the double wishbone for better, especially normally that one is for off-road vehicles. Okay, for McPherson, you see the main difference is instead of having two arms, the previous one, we have two arms here. We have the upper arms and lower arm. For McPherson, we have only the lower arm and we have the strut here, which consists of the spring and also damper. So McPherson is very good in terms of reducing the vibration or isolating the vibration that being transmitted to the passenger or the person inside the car. So in terms of comfort, McPherson is one of the best suspension. In terms of the design, very simple, hence the price is very cheap as compared to the double wishbone. So I did change my suspension a few years back. If I'm not mistaken, for mine, I'm using Toyota Vios here. If I'm not mistaken, total for one suspension here, not two. For one suspension together with the labor cost, it cost me around 250 only. So it's quite cheap. Okay, so you can imagine if this one is 250 for double wishbone, the price should be more expensive as compared to this one here. Okay, but the one of the disadvantages is it doesn't cater many degree of freedom of the dynamics of the car. It's only good for vertical vibration mostly. So mostly we use this car for on-road car. For off-road, so this one is not really perform well as compared to the double wishbone. The third type of the passive suspension is almost similar to the double wishbone, but we call it a multi-link. So here we see we have three links. We have one link, the lower arm, the upper arm, and we have one vertical here. Okay, so this is more, you see the design, okay, it gives more flexibility as compared to double wishbone suspension system, okay. Hence, it gives more performance, a better performance in terms of handling and also the comfort. So in terms of performance, okay, I'm going to say that this one is much better as compared to MacPherson. Okay, the disadvantage is the design here. So since we have multi-link, okay, so the design is more complicated, okay, hence the cost that incurs. So the price is more expensive as compared to MacPherson and also more expensive as compared to double wishbone. That's why not many cars, I don't think, I'm not sure which cars are using now, but for double wishbone and MacPherson is the one is widely used. Double wishbone still used. This one, I think I'm not sure. I cannot say. Not many cars are using this anymore because of the price and also because of design. But in terms of the performance, it's better as compared to MacPherson and also double wishbone. Okay. Okay. The next one is the leaf spring. Okay, this one is completely different from the three that I have discussed. In the three that I have discussed, it consists of linkage. We have spring, we have damper, but this one we have only springs, layers of springs made by steel, okay, hardened steel. All right, and the one, the longest one here, this is what we call master spring. The one at the bottom or the shortest one here, this is what we call DI. Okay, so this is one of the example of what I mentioned just now, the dependent suspension system. You see these two wheels here. The one here, the rear one, is connected by the axle. The two wheels are connected by the axle, and the suspension system here, the leaf spring here, is connected to. It depends on the model. Sometimes it's only attached to one of the wheel. Sometimes attached to both of the wheel side by side. Okay, one of the advantages, sorry, not the, one of the advantages of the leaf spring, it can support a very high load. So that's why most of the time this suspension is still used. You can see it's still used for heavy vehicles like trucks, pickup trucks, van. I'm not sure. I think vans are using a normal suspension that we have previously discussed for the three types. This one more normally lorry, trucks, and pickup trucks. Train, I don't know. If you ask me, trains, locomotives are using leaf spring. That one, I'm not sure. Okay, but this one, on a daily basis, I can see that some trucks, some pickup trucks are still using this. Okay. All right. So up until here, so that will be everything about what the commonly used passive suspension system. Like I said, you see all the suspension system. Okay, they don't require any external force. They work well in some degree of the performance. I'm not saying it can work both well for handling and also the comfort, but at least it works well in handling or it works well with in terms of comfort. Okay, and it's very, very cheap as compared to active suspension system. The reason is because it doesn't require any external power. Okay, right. Before I move on to the active suspension system, okay, so why people has changed into adaptive or active suspension system? Why still they don't want to use? Okay, why they want to change? Okay, they want to shift from the passive into active. One main reason, okay, one main reason why they want to change that is because they want to get both performance. They want to get a good handling as well good comfort for the same vehicle. For example, the same vehicle you're gonna use that vehicle for on road as well as off road because what happened for the on road vehicle doesn't work well on the off road. in terms of the comfort and also and handling. For off-road vehicle, it doesn't work well on the on-road vehicles. Okay, I give you one example. Simple example. The researchers, they call it two different types of suspension. We call hard and soft suspension. For normal car, sedan car, the one that we use, they call it soft suspension, meaning that the value of the spring, okay, is around, again, it depends on the model of the car. It depends on the type of the car. So the value, the spring stiffness is around 100,000, and the value of the damping, of the damper, shock absorber is around 2,000 Newton second per meter. Okay, so with that, it works well, okay, in reducing the vibration that goes into our body. Okay, but if you use that for extreme driving condition, okay, in terms of handling, okay, if you take a sharp turn, like I mentioned just now, you can feel that the vehicle, sometimes it happens, sometimes the vehicle roll over, okay, or if you use your vehicle on the off-road, then you can feel that all the vibration and the swaying of the vehicle moving this direction, back and forth, up and down, left and right, all this um, discomfort and all these dynamics happen to our body because the suspension cannot cater that. Okay. On the other hand, for a sport car, okay, or racing car, they use a hard, we call it hard suspension. Okay, meaning that the spring stiffness is very, very high, and also the value of the damper is also high as compared, I think, almost twice as normal domestic car. So as a result, even though they move at high speed, they make a very sharp turn at high speed, the tires or the wheels still stick on the road. It's still basically balanced. It doesn't lose the balance uh, at, at the extreme driving condition. So the active suspension system, what they want to achieve is to get both of these two conditions. So they want to have good handling, like a racing car. At the same time, it also want to achieve a good comfort for a normal sedan car. Okay, so how to do that? Like I said, we have to introduce an actuator. Okay, and it can adapt to all driving conditions, all the vehicle dynamics, all road conditions. Okay, and that actuator is basically is controlled. Okay, controlled by a control panel. And in order to do that, so they install many sensors throughout the body to measure the dynamics or the motion of the body of the car as well as the wheel. And some of them, some type of active suspension, they measure also the direction or they anticipate the the irregularities of the road, meaning that they have a sensor to detect the road roughness few seconds before the vehicles reach that particular area of the road. Then the suspension will basically anticipate the roughness of the road accordingly. Okay, so there are many types of suspension system, but the one that I'm going to discuss, or the most important or most popular one, they are Bose suspension. Okay, we have Magnetological and we have ABC, or the active body control, which widely used by the Mercedes-Benz nowadays. Okay, right. So the first one is the Bose suspension. This one is being invented by one of the professor in MIT. If I'm not mistaken, his name's Amar Bose, one of the professor. It's been going around for 30 years now. Unfortunately, okay, unfortunately, the reason I say unfortunately, it hasn't been put into practice yet. Okay, he called under the Project Sound before. The reason he called the Project Sound because the concept of Bose suspension is similar to the one that we have in our speaker. So he looked at the speaker. He's the sound engineer, basically. Okay, the professor is a sound engineer. So he looked at the speakers. He got the idea from the speaker. He said that from the speaker, the speaker, when the speaker is going to make a sound, so the amplifier would tell the diaphragm of the speaker to move front and back, and that vibration of the diaphragm will produce sound. So from that idea, he came out with a suspension system, which has two important parts. One is the actuator, electromagnetic actuator or electromagnetic motor, which controlled by a power amplifier. Okay, so it requires a lot of sensors connected to the body and also the wheel of the vehicles. So this sensor will detect the direction or the motion or relative motion between the wheel and also the wheel and also the body of the vehicle. So whenever there is a discrepancy, because the aim is to keep the level of the vehicle as constant as possible. So whenever there is a different or relative motion between the two, so what happens? The control panel or the control board will tell the power amplifier, and the power amplifier will tell the motor to either extend or or contract accordingly with the dynamics of the car that happens at particular time. So the response is very, very fast. They claim that the response is around 3 milliseconds, very, very fast here. Okay, unfortunately, I think if I'm not mistaken, again, if I'm not mistaken, it has been tested on Lexus, and around 1990s, the project has been stopped and has been changed ownership to, they call it Clear Motion Project. Initially, it was called Project Sound, and then it was sold to different company called a Clear Motion. If I'm not mistaken, that one is around 2017. Okay, and one of the reason they say that they haven't put this into practice because of the bulkiness in terms of the size and because of the cost that incurs onto this actuator. Okay, so maybe I'm not sure. Maybe you can think of this something like this into our FYP for our student later, yeah? Because this one has been going on for almost 30 years. I think it's more than 30 years. So within these 30 years, we have advance in the development of technology and everything. So maybe we can think of something cheaper, something smaller in terms of size, but will have the same effect as this one. So maybe this one, as a student, you can think this one of your FYP title. It's a good title, yeah? Okay, so like I mentioned just now, so the electromagnetic motor here instantly counter the effect of the road irregularities by means of power amplifier. The power amplifier will instruct based on the feedback by the sensors, which they apply on many parts of the body of the cars and also the wheel. Okay, and then they have control algorithm to tell how much the motor has to bring the strut to go up or to go down, to extract or to extend. And then this is one of the layout, yeah, that I found from the internet, how they install this Bose Suspension. Okay, like I said, this is an independent. It's been installed to each independent wheel, front and rear. Okay, and all these are controlled by a control unit, which get the feedback from the sensors throughout the body of the car and also the wheel. The next type of the active suspension system, or the active, one of the popular one is the Magneto-Rheological suspension or Magneto-Rheological shock absorber. Okay, so what happened is the original shock absorber is been replaced by a Magneto-Rheological shock absorber, which let me show you the figure. So this is the shock absorber. The normal shock absorber, we have a piston inside here, and inside here we have a oil-like substance. So this oil substance is replaced by magnetic particle suspended in fluid. Okay, so what happened? Here we have electromagnetic actuator, which gives the magnetic field of different values depending on the road conditions and depending on the dynamics of the vehicles, which we discussed just now. So for every different values of magnetic field produced, it will give a different resistance of the motion of the piston. But we can consider this as piston. It can give a different resistance. Okay, so for example, if the car is hitting a pothole, so the car is basically going down by a certain centimeter, so the power controller will tell the electromagnetic device here, okay, now produce some magnetic field of certain amount such that the resistance is this amount, so that the body of the car won't go down or is moving up opposite direction. Okay, and the thing about the Magnetological, sorry, okay, is very, very fast. Okay, the response time is around 1 millisecond. Okay, and it has been used by many cars. They started using this in 2002 by Cadillac car. Then it has been used by Chevrolet, Camaro, Ferrari, BMW, and I think for coming model of the car, many of the cars are using this. Okay, one is they still keep the normal spring. Okay, the conventional spring is still there, but the conventional damper is replaced by the magnetic or the Magneto-Rheological shock absorber, something like this, which is controlled. All right. The last one, okay, the one that I'm going to discuss is the active body control, sorry, ABC. And it's one is being used mostly by the Mercedes. Previous year, they call it ABC, active body control, but quite recent in 2020, if I'm not mistaken, they changed the name to E, active body control. Okay, so it works basically. What happened from the conventional suspension system? They remove the conventional shock absorber and they change into both air and hydraulic servo mechanism or pneumatic and hydraulic servo mechanism actuators, right? So the aim is basically to keep the vehicle level constant. For active body control, okay, I've seen one of the video which they put it on the YouTube. They run some simulation, they run some experiment on one of the car. They put the glass of water on top of a car. So the car is cruising across road with different conditions. They have bumpers, they have potholes and everything. So you can see that the level of water remain almost consistent. So it shows that how the active body control works. Basically, what it does is basically to keep the level of the vehicle at one particular position, regardless you are hitting the speed bump, you are hitting the wheel is going into the potholes, or you're driving on road, or you're driving off road. So it works similar, or the vehicle level is maintained at one particular, or they call it the relative displacement between the wheel and also the body of the vehicle is consistent. It maintained at one position. For E-active body control is even more interesting. Okay, so the reason they call E-active, they have one control panel now on which you can manually increase or decrease the motion of the suspension. Meaning that, let's say, at one point, okay, during the driving condition, for active body control, the control will be controlled by the control panel. So the control panel will tell how much the actuator is going to move up or how much the actuator has to go down based on the driving conditions. Okay, for E-active body control, the reason I say it's very interesting is because it works the same way as the active body control, but on top of that, okay, they provide a control panel on a dashboard where you can control the suspension to move up and down at any time that you want. Say, for example, during a normal driving condition, you want the front suspension to move up by 5 centimeters, the lower to go down by 3, and meaning that your car is like moving like this, tilted like this throughout the journey. You can do that. Okay, apart from the automatically controlled by the suspension, by the control system itself. So you can also manually. So in a video which they showed, okay, basically you can interchange, for example, on the front wheel, the left hand side move up by 4, and then after 2 seconds go down, and then the rear left hand side of the wheel move up by 3 centimeter and then move down, and basically you can keep on moving the vehicles up and down, and they call it a dancing vehicle. Okay, because you can manually control, okay, as well as automatically controlled by the system itself. All right, so that is basically all about the active suspension system. So if you ask me, is there any other type of active suspension system available in the market? There are many. Okay, it's not just this three, but the reason I chose this three because this is the one that most popular and widely been researched by people. And in fact, yeah, the one that used by the Mercedes here, ABC here, active body control, is basically been used by Toyota before. The initial development was by the Toyota, but it never been made into practice. The Toyota is used the active body control as well. It's almost similar using pneumatic and hydraulic servo mechanism. But the difference is the Toyota one, they remove the spring instead of damper. Mercedes, they take out the original damper and they replace by the ABC. Toyota, they remove the spring, they keep the damper, and they combine that with the AN or pneumatic and hydraulic actuators. Okay, but the Toyota, if I'm not mistaken, the development stopped in 1995 for some reason. Okay, I think one of the main reason why people are still not using or why the development is still undergoing for active suspension system is the price. You know the price for active body control here? The one that I mentioned just now, yeah, the one I mentioned for my car using McPherson, if I want to change one McPherson strut, okay, one suspension, it cost me 250. So if I want to change a fluid, is magnetic fluid, okay. Like I mentioned, yeah, sorry, I'll come to your question later, okay. Like I mentioned, the one that I changed for my car, the two side or the two suspension, the two sets only cost me 500. So if I were to change all four sets, front and rear, that will cost me only 1,000 ringgit. Okay. And how much is active body control for Mercedes? Okay. The whole set or whole four, not including the installation, yeah, is $8,000. So you can imagine lah. So why active suspension system is still, some of them still undergoing the research stage. Some has been made into practice, but not all cars are using. Mostly for Mercedes now, starting 2020, they only installed it for S class only. Okay, they didn't install for all classes. So only S class are using this. Okay, even though the one that Magnetological I mentioned, even that one is in terms of price is cheaper as compared to ABC, but not all models of car. Even though for Cadillac, Chevrolet, Camaro, Ferrari that I mentioned just now, not all models are using that. Only a certain model. I think the main reason is because of the cost. Because the cost is too high, and the performance that you get as compared to the passive. Because now, for the passive suspension system, I'm not saying it's not good. You can tune that, you can design that. Plus, now the road conditions are getting better as compared to the previous. The long time ago, the road conditions we don't have the asphalt road. Everything is like normal soil. We have stones, small rocks, right? So that's why the driving conditions was very, very bad. But now, as the technology advanced in terms of the engineering, so the road conditions has getting better and better. So the passive suspension basically can cater the performance, the good performance. So maybe I'm saying maybe I'm not so sure about this. So maybe that is the one of the main reason why car manufacturers still sticking with the passive suspension. Only some luxurious model they change into active suspension system. One thing, they want to improvise further the performance first. Second, maybe I'm not sure. Maybe they want to find a reason to increase the price of the car. Maybe I'm not so sure. Okay, so in general, okay, the active suspension system, okay, the performance is much better as compared to the active. Okay, but it comes with a bad side, which are it requires an external power, it requires with sensors, requires with control algorithm, and hence it costs much more expensive as compared to the passive. So if you think that you get, for example, twice the performance, but the price of the car goes by 10 times, then if you think that worth it, then you can change your suspension into active suspension. If you think that, okay, this is the performance, the level of performance of passive, and if I use an active, it goes up by 1.5 times, or let's say 15 times in terms of the efficiency or in terms of performance, but the price goes up by 4 or 5 times more, or 10 times or maybe. Okay, so if you think that doesn't worth it, then let's stick with the passive suspension system. Well, anyway, the option is yours. Okay, so as an engineer, you are going to one that going to make the decision yourself. You think that, okay, I can make a passive suspension system better with different arrangement, different value, or different combination of value of, because we can still do some modification in terms of the values of the spring stiffness and also the value of damping that we can use for our suspension. Okay, and if we are using the double wishbone, like I said, so we still have some um, flexibility in terms of design. For example, the length of the arm that we can use, the angle of the upper arm as compared to the lower arm, and how the size of the ball joint that we can apply. So all this design, the changes in the design would give us difference in the performance of the suspension. So like I said, that is entirely up to you. So if you think that, okay, now is the time or the era for everyone is going to use active instead of passive, then maybe as an engineer, future engineers, you can think of something of how to bring the cost down, because now the cost for active suspension system, like I said, is very, very expensive. Okay, and sometimes the ship is very, very bulky. And like I said again, now advancement in technology, okay, we have nanotechnology, we have advancement in microcontroller. Maybe you can think of something that can make the active suspension system more robust, okay, more cheaper, okay, in terms of the size, more flexible, and maybe more compact, so that it can be replaced the passive suspension system, so that everyone, okay, can have a better ride and also good comfort while driving their by driving the cars. Okay, so I think until here, so that's all about my presentation. So I'm sorry if I took too long for your time. Okay, so if you still have any question with regard to suspension, either active or semi-active or passive, you can ask your question in the chat, or you can basically, I think, if you're allowed, you can also unmute yourself and ask me the question. I try my best to answer the question. Okay.
Yes. Thank you, sir, for that informative session. Like, I can imagine what the situation of the cars would be if there were no suspension systems. Like, one bump and the car is gone if there's no suspension system.
Yes.
Yes. So I actually had, like, I would like to use this opportunity to, like, I had some questions of my own. Like, is there any way to simulate these vehicle suspension systems?
Yes. Yes. By right. Okay. The development of suspension system, they do the simulation first. Okay, so they run the simulation in MATLAB or that. I think in our university we use a lot of MATLAB and LabVIEW. Okay, so you can model your vehicles, the suspension system, okay, and then you can see the performance based on that simulation results. So once you have obtained that simulation result, then we apply that into practice. We have the experiment to confirm or to validate our results. So I did some of the simulation back in Sheffield last time, using single degree of freedom and two degree of freedom system. This one is mostly on the vertical vibration, where we cater mostly on the comfort, not on the handling, mostly on the comfort. So we try to figure out what would be the best combination for the value of the spring stiffness and also damping to provide us the best driving sensation, especially for the road conditions in Malaysia. So we did that simulation last time and we get some of the results. Yes, to answer your question, yep, we can do the simulation. Okay, and normally after once we have obtained the result from simulation, then the value we use for our experiment to validate or to verify our results.
Okay, thank you, sir. We have some questions in the chat.
Yes,
From
Shane is asking, how does a suspension system change the ride height of a car? It's like pumping, damping feet in and out of the absorber. Okay, why some car can adjust it slowly? Yes, that's correct. Why some cars can adjust it slowly and some can change quickly? Okay, that it depends on what type of the actuator that we are using, the absorber. So some are using air suspension, some are using hydraulic. Okay, the one that goes up and down quickly are using hydraulic. The one that use slowly is using air. Okay, the one is using air mostly now in, I think you can see if you ride bus. Okay, most of buses nowadays are using air suspension. So you can see that when they stop by, you can see that the level of the body of the bus goes down and sometimes goes up slowly, so that they pump the air into that. Because, okay, sorry, because they are using the pump there, so the pump is connected to the suspension. You use air suspension or pneumatic suspension.
Okay, thank you for answering Sharon's question. There's another from V. Lee. I just wanted to ask, how would F1 car suspension work with no springs or shocks?
Hey, says who? F1 car, they have spring and shock on the side of the, they have, they have. Like I said, it still work without, but if you do that, the car still can move, but what happened is without any suspension, then the dynamics of the car will be applied. Everything, all the motion of the car will be uncontrollable to the vehicle body and also the person inside the car. Okay, they do
Hello,
have,
sir. Oh,
yes.
sorry. You finish first, then. At the... Hello.
Yep, yep.
Yes.
Oh, okay. My question is: the suspension system is part of the unsprung mass, or
Uh-huh.
is it part of the unsprung mass of the vehicle, like the tires?
Okay, so basically the tire itself also acts as a suspension system. Okay, since you mentioned about the unsprung and sprung mass, so I think let me just explain to some of the floor. Yeah, maybe they don't know what is sprung mass and unsprung mass. Okay, so we have two levels of suspension. Okay, basically we have the shock absorber and the spring itself. Also, the tire itself, it has the property of spring and also a damper. So the tire or the wheel, okay, it's also a part of the suspension or sprung and sprung mass. Okay, so overall, that's what I said. To control the suspension, most of the research, okay, they concentrate on the unsprung mass and sprung mass, which is the spring and absorber. Okay, but if you say that what is a suspension system, what is a total suspension system, then yes, that includes tire. Because what happened, um, the the road irregularities or the road displacement, first it goes to the tire. So the tire itself or the wheel itself will isolate the vibration first level, and that vibration will be transmitted to the conventional spring and damper. Again, it will be minimized or will be isolated by that. And then we have another level of suspension, which is the seat itself. Okay, this one also important because the seat, the one that we have in our car, is also act as another suspension system. That's why you say that why when I ride a car, I don't feel that much vibration as you mentioned. For example, if I ride, so why is it very? You said just now, the vibration can give harm to my body because we have basically three levels of vibration. Three levels of vibration control: the wheel, the suspension, and the seat.
Sharon, yes, Sharon commented that F1 cars use push rod suspension. Is it correct or wrong?
That one I'm not sure. Because the one, okay, the one that I know of, they still have you. But maybe you're right. Sorry, yeah, sorry. So this one I cannot answer because I think they use spring and damper. But if you see the push rod, then maybe you are correct. Okay, I'll look into that.
So just now I asked the disadvantage of the multi-link because I noticed a lot of sports car they use double wishbone setup, but then multi-link is better than double wishbone. Why do
Yeah.
they use double wishbone instead?
Okay, the reason they don't use multi-link, like I said, one of the disadvantages of multi-link is in terms of the design. Okay, because it's complicated, it has many links, so in terms of design, it's more complicated, and hence the price is more expensive as compared to the in terms the price is more expensive as compared to the double wishbone. Double wishbone is slightly easier because you have two arms only, the upper and lower. Multi-link, the upper arm, they might have another link, or maybe they have 2 or 3 more links. So in terms of design, it's a bit more complicated now.
But then for race car, I don't. Do they like still consider the cost because they just want to get the edge, right?
Okay, that one I can't say now because anything about that, because the manufacturer, okay, all the car manufacturers, everything is all about cost. So the reason why the Bose suspension is not being implemented, the main reason is because of the price. Okay, the reason why people has changed to McPherson instead of the double wishbone, even though double wishbones perform much better as compared to McPherson, because of the cost. So as long as if you are one of the board of director of that company, maybe then you can answer that question. I honestly, personally can answer that. But in terms of
Okay.
performance, yes. In terms of performance, yes. Multi-link is perform better as compared to the wishbone. But if you ask me why don't they install that, the only reason I can say is because of the in terms of the difficulty or the complexity in the design and also the cost. But if there any other reason why they don't install that, then that one I don't know.
Okay, sir. Thank you. I couldn't find it in internet.
Engineering speaking, yes, it performed better.
Thank you, sir.
Is there anyone else? We have a question from Duo Lee. The function of brake bones is to fix the location of spring. Is it correct?
What is brick bones is? What do you mean by brick bones?
You can unmute yourself and ask the question if you are willing to.
Can you explain to me what do you mean by brick bones? This is a term that I'm not familiar.
Yeah.
So what do you mean?
Yeah.
Oh, the metal link. So location of the spring. What do you mean? Okay. What's wrong with the location of the spring? That need to be fixed. Can you explain to me, since you mentioned brick bone, so what is basically wrong with the location of the spring? Oh, the sway bar. The sway bar is different. The sway bar is different. The sway bar is the one that connects between the two suspension, front or rear. The sway bar is to basically to counter the rolling motion of the vehicle. But the brick bones, I honestly never heard that. The sway bar is two different things, yeah? The sway bar, no. Rudy, maybe you want to clarify me. Maybe you want to clarify the location of the spring. What do you mean by to fix the location of the spring? The location is, because I don't understand what do you mean by to fix the location of the spring. Oh, wishbone. You mean the wishbone? Oh, okay, not brick bone, the wishbone. Okay. So the wishbones is to attach. Okay, there are two wishbones, the upper and lower. Okay, basically it's to attach the suspension to the chassis of the vehicle, to the body of the car. And as the car is moving, it has the rolling motion, pitching, sway, yaw motion. So the wishbone is the one that try to damp out the motion or to counter that motion. So that is the use of the wishbone. The spring and the damper is mostly on the it gives some effect on the other degree of freedom, but mostly is on the vertical motion of the vehicle. The brick bones, I don't know. If you say the wishbone, yes, the one that I mentioned just now.
Is there any other questions someone want to ask?
And also, if you ask me about the price for MacPherson here, again, it depends on different model. Yeah. So for Proton, maybe it costs differently. For if you're using Nissan, maybe it costs differently. So that one I cannot say for sure, but in average, it's quite cheap as compared to the other type of suspension. Okay, the one that I mentioned, 250 is my own experience. So maybe Proton, maybe 180. I don't know, maybe around that value. The bigger the size, then it's more expensive.
Any other questions? If there isn't any question, I would like to ask.
Can I add something?
Yes,
since
yes.
Since there's no other question from the floor, let me ask you. Okay, so that whether you understood this or not. Okay, a very simple question. Some of the youngsters, they did some modification on their suspension, meaning that they cut the suspension to become shorter to make the look of the car more sporty and nicer. My question is, does that compromise the performance of your suspension? After you have listened to my presentation or maybe some of the knowledge that you have, okay, making the suspension or absorber shorter, or in Malaysia they call it by cutting it shorter to make the look of your vehicle sporty and everything. Does that compromise the performance? Okay, in what way, Harim? So if it does, in what way? The river hand, that is correct. Because one of the suspension system, okay, one of the suspension is to protect we want to have some relative displacement between the wheel and also the vehicle. So we want to keep it as certain value. We don't want it to be as small as possible, because if it's too small, then what happens? The suspension will hit the body and can cause dent to your body of the car. Well, you can feel that, yeah, if you hit a bumper at high, not really high speed, but slightly high speed, you can hear the sound. So that means that the suspension is hitting the body of the car. So if does that happen many times, then it can dent and damage your body of the car. That is correct. That is correct. Okay. Good, good. Meaning that you have understood that. Yes. But many people are doing it, especially youngsters.
I have a last question. Which is a good coilover brand that you would suggest?
The good what?
Coilover brand.
Oh, the coil brand. That one I cannot answer. Those who have done FYP, they should have known what brand is good. Olin. I know the good tire brand, Michelin, but the coil or the spring, I'm not sure. Because normally when I replace mine, I use the original Toyota. So I'm not sure which one, what brand they used.
Okay.
Okay.
So anyone has any other questions to ask? If not, then we'll proceed. So thank you, sir, for being with us today.
Thank
It
you.
was a wonderful session, and it was wonderful having you here with us. Also, I hope to see you again soon in future Tech Talks or events. Also, I would like to thank all the attendees and viewers for joining us to this informative session. I would request everyone to scan this QR code and fill the feedback. It would be really helpful for us to improve for further future events or tech talks or any workshops which we host. So again, I would like to thank Dr. Syed Mohammad Bahrain to be with us here today. And I hope everyone has a great day and a great weekend ahead. Thank you and goodbye. Thank you, sir.